Okay, so we have question 2 here, and we want to see if we can show, if we can find the horizontal and vertical components of the moment at P due to this force here, force F. So the first thing that we do is, always, is we know that a force acts along a line of action. No matter what direction that force is in, it has a line of action. So let's see this line of action of this force. And to find horizontal and vertical components, we can turn that force, that becomes the diagonal of a parallelogram, which has a vertical part and a horizontal part. Draw a little parallelogram here, and that's always the way of finding the components. Make the force the diagonal of a parallelogram. Now, we want to know what these components are. Well, we have to find out, if we know this force F here, we need some trigonometry to find these components. Well, we know this force here acts at 115 degrees. So we know that that angle there is similar to this angle up here, using horizontal here and the same line there, so that has to be 115 in here. And totally along a straight line the angle is 180, so we know that this angle here is 65. Okay, so that's the angle that we are looking for to try and find the components, because now we've got a right angle triangle, and we know that the vertical component here will be F sine 65. And we know that this horizontal component here, which is the same as the horizontal component along there, that there will be F cos of 65. So now that we have those components, we now have to find the moment due to each component. How do you find a moment? Well, for any force, you take its line of action, and then you take the perpendicular distance from that line of action back to the point. And here, this is the point that we're considering. So for the vertical component, we have to take its line of action, which is up here, this way. I'll just get rid of this here. The line of action is going up here, this vertical component, and its distance is, the moment arm is that distance there. As we can see, that's 9. So we know that this force here, this vertical force, has a moment arm back to the pivot point of 9. So the moment due to this force here, we'll call it the moment, the vertical moment, is always the force times its perpendicular distance, which in this case is F sine 65 times its perpendicular distance, 9. Similarly, this horizontal component, this is its line of action along this horizontal line here, and it has a perpendicular going back to the pivot point, which is of length 12. So the moment for the horizontal component is equal to force times perpendicular distance. So the force is F cos 65, and the perpendicular distance for this force is 12. So there you have it, the vertical and the horizontal components for this force here. Now, of course, we need to find the direction of those, so we know the sign. Well, if we know that this vertical force is going down here, okay, so it will be creating a twisting action around P in this direction, the clockwise direction. so we know that it is negative. This horizontal component, you can see it's twisting around P in the counterclockwise direction, in that direction. So it's coming out here, we're going around P in that direction, so we know that it is positive. So there we have it, the vertical and horizontal components and their signs.